This is the second part of the multi-threading in Java. I assume that you have already seen part 1. In this part, I want to do some coding related to the topics that I discussed about them in the first part. I'm using IntelliJ IDE. You can use whatever IDE you want, for example Eclipse, NetBeans, and any kind of IDE. I create my entry point, my main class, having a static method as main, and first I start to creating a thread, starting it by implementing the runnable interface. So I create another class. The shortcut for this new context menu is Alt Insert. You can use it in IntelliJ. So I create class, I call it, for example, my worker. In my worker class, I implement runnable interface. So as you see the red squiggle behind this line, it will tell you that you should implement the method of this interface. The shortcut for doing this is pressing Alt Enter, then clicking on Implement Methods. Here is the list of the methods that are actually abstract methods in the runnable interface. As I told you in the first part of the tutorial, the runnable interface is actually a functional interface having only one method, and this method is run. So here in the run method, I write some code. Assume that is the main logic of this thread. What is this thread actually do? For example, I write some output to the console. Okay, I keep it simple for this part. And in the main thread, because the main class is also is a thread itself, is the main thread of the program. If you have some other threads, the main thread can be also executed parallelly and also in a concurrent manner with other threads. So here I also write some information to the output, and then I want to create an instance and start my worker. As I told in the first part, when you are using runnable interface, you can't start it by itself. You should use a carrier thread. So I use Java lang thread class. I give it a name, for example T1. I will create an instance of it. It has different kind of constructors. You can, for example, only pass a reference to your runnable to the constructor of the thread. Also, you can give it a specific name. So I doing it like this. I new my worker and also giving this a name. For example, my thread 1. And then you can start your thread. At the end of the main method in the main class, I also write some output. And I run. As you see in the console, you have seen that we have printed main begin, then main end. I will tell you why this happened, and then beginning of the run method, doing something interesting, and of the run method. Well, because both of these classes, main here and my worker, both of them are threads from the view of operation system. Operation system in this case can be Linux system or Windows. Each of them has their own implementations of how to deal with threads. When I run my program, the operation system will decide to give the CPU cycle to which thread and when to get the CPU cycle from the threads. So here the OS decide that give the chance to the main thread to do and go through its execution path. So main begin has been written in the console, and then the CPU gets its chance from the main thread and give the chance to the my worker thread, and doing a context switch from main thread to my worker. So here you see that the output of this has been written in the middle of from here. You may expect that you see main begin, then this, and at the end main end. But the CPU give the chance to main thread to do all its execution, and then context switch to the T1 thread. So you see all the output of my worker thread after the output of the main thread to the console. If I want to change this, I can do something like this. For example, I can use thread sleep here, thread sleep accept input parameter as milliseconds, so I give it 3000 milliseconds, and it should be wrapped in a try catch method for handling interrupted exception. I will discuss about it later. I run the program again, and you see the same output. I move this one after start. I'll run it again, and now you see that main begin has been written into the output in the console, and then this output from my worker, and again we're back to the main thread and having this output. Okay, I will discuss about these issues and many other issues in detail in other parts of the tutorial. Also, I will talk about synchronization, thread yielding, joins, executor service, concurrent, collections, and many others in other parts. Well, I back to the main topic. As I told in the first part, another way of creating a thread is extending the thread class. So here I press Alt Insert again. I create a class, I call it task. I extend thread class here, and now I override the run method, and here I write some logic, simply writing some string to the console. My task in my task method. I pressing Ctrl plus D to duplicate these lines, and then I change them somewhat. Okay. I keep it simple for this tutorial, for this part of tutorial, and then I'm back to the main menu. You can use Ctrl Tab in order to switch between the open clusters. Also, you can use Ctrl plus E shortcut to see recent files and switching between them. It's a very convenient way. Okay. For the moment, I back to the main thread, and here I create my task. Excuse me. My task, and give it a name. In this case, it's not necessary to use a carrier thread. You can start my task here. How should I delete this? When I use the runnable interface, I was forced to use a carrier thread in order to start my runnable. But because my task is itself a thread, because has extended thread, it doesn't need a carrier thread. I can start it explicitly. So I call the start method of my task, and then I run. And as you see, these are the outputs from my task thread. And again, these outputs are after this line. As you see, as the fellow in your code, you may you may expect that the main end be displayed before the output from my task. But as I told, because main is a thread, CPU decide when let the threads to do their execution. Even in the middle of a thread execution, for example, I may have many lines here. The CPU may decide to get the CPU cycle from this thread. For example, after printing this line to the output, the CPU may context switch to another thread and give the chance to another thread to do something else and go through its own execution path. Okay, also another thing that may be interested for you regarding here, instead of implementing runnable interface for a specific class, you can use anonymous methods and also lambda expressions in Java 8 for creating and running a thread. This was the first way. As you see, I have implemented runnable interface, then use carrier thread. Another way is using anonymous methods. So it is like this. Here I new instance of the runnable interface and anonymously implementing the run method without giving this instance a name. Here I write some output. Anonymous method. Something like this. And again I run my program. You don't see anything because I have not started it. So I started. Okay, here you see the output from the anonymous method. And another way for creating and starting in Java 8 is using lambda expressions. I will show you a fast, simple, and an encrypted way for doing so. A new thread without giving it a name. Then here I'm using lambda expressions, and then writing some output to the screen, lambda expressions. And then starting it. So all things at one line, as you see here. All things at one line thanks to the Java 8 feature and lambda expression. So I run the program, and you see here lambda expressions has been written to the output. If you want to have more line here in your lambda expression, you can do something like this. For example, I repeat it again like this, and here I give it a multi-line lambda expression like this. Lambda line 1, you can have many lines here using block of lambda expression. You should open the block and close the block. Okay, I start the program again, and you see all the lines have been written to the output. You see them in the console. Well, and also, for example, I can, when I extending the thread, I have many properties, many methods that I can use them. For example, in this runnable it's not possible. In the task, because I have extended the thread, I can use thread methods here. For example, I can output the name of the thread using getName, or you can use also this here getName. Doesn't matter much. Okay, well, run the program again. You see the name has been written to the output here. This name has been defined by the program itself. I can give it a name by myself. Going here, give name excuse me in runnable. I can do this here because I have extended thread. I should be using the setter method. I give it a name, for example T1, and I start the program again. Okay. And you see that it has been written to the output TTT1. In runnable, I have passed the name through the constructor, as you see here. So in my worker class, I can act like this. Here we don't have something like getName, as you see. Another way to print out the name of this thread here is like this. Again, using the thread class, it has a method called current thread, and from it I get the name. So I run the program again. We see that my thread date has been written to the output too. To make it more clear, I change it like this. And you see here the name, and this one the name for the thread extended from the thread class. This one the name for the thread implements the runnable interface. Okay, now I want to hack through the thread class itself. So I go to the my task, I hold down the control on my keyboard, then pressing on thread class. As you see, it is in java.lang package. As you see, it has many properties, fields, and methods. If I go to the runnable, as you see, it has only one abstract method, and it's a functional interface because it has only one method. Well, I back to the thread class, I'm pressing Ctrl F12. You see here methods: get name, get priority, get a state, as I discussed about the state in the first part, and many other methods that I will explain all of them in detail in other part of this tutorial. For simplicity, in IntelliJ IDE you can then you can create the diagram of this class. As we see, this is the hierarchy related to the thread. For example, the thread itself has implemented runnable, as you see here. And also I can see the fields these are the fields. As you see here, fields in IntelliJ IDEA means that these fields have not been used in this field has no setter. For example, min priority, max priority don't have any setter, but all these fields that you call it property, all of them has setter getter methods. Okay, these are the fields and properties of the thread class. Also, here we have different kind of constructors for the thread. As you see, without any argument, a constructor that only accepts runnable interface, and this one here, a constructor that accepts runnable and a string as a name, as you see here. And also you can see the methods here. For the sake of simplicity, I disable the properties, fields, constructors, and as you see here, these are the methods. I will discuss about them in detail in future. For example, set demand is a very important method for threads. Demand thread means that they will be ended whenever all the main threads of your program have been finished. So if there is not any other thread in running state and all of them terminated, the daemon thread will be terminated automatically. It is not necessary that you end it or shutdown it. After ending all threads, the daemon thread will be terminated automatically. So it's very good for some purpose. For example, you can use it for monitoring. You can use a daemon thread for monitoring other threads. For example, monitoring their states, behavior, and many other things. And another important method here, as you see, is getting the state of the thread. You can see which state the thread is currently is. And these methods are also very important. I will discuss about them more detail in other parts of the tutorial. Join methods are also important. Also, you see get name here and set priority. Set priority, accept an input parameter as integer type that is maximum of it is 10. The thread priority can be set to, for example, 1, 2, 3, 4 up to 10. And based on the priority, CPU give the cycle to the threads oftenly with more priority, with higher priority. Well, I think it's good for the moment. And if you want to see the states here, okay, as you see, the thread has an enumeration of states. I go to the source of this, and as I discussed in the first part, New is one of the states. Runnable or running is another state I discussed about in the first part. Blocked and waiting are other states that are very similar to each other. For example, when you using thread asleep, the thread will go to the waiting state. But when the thread is waiting on a monitoring object or waiting for a synchronized method to be released, it will go to the blocked state. It is very similar to the waiting state. Another one is timed waiting. It means that, for example, you have used thread asleep for 3000 milliseconds or 4 seconds, 5 seconds. Then it goes to the timed waiting. And the terminated state that I discussed about it in the first part, the terminated or dead state. Okay. Well, I think it's good enough for this part, and I will prepare another part and the third part as soon as possible. Thanks for now and take care.